Richard, can you just confirm you can see my slides, please?
I am, Nick, yes.
Thank you. Again, good afternoon, everybody. If you wouldn't mind holding questions to the end, it'll just make life a bit easier as obviously doing this via Teams, but happy to answer any questions at the end. So thanks for everybody time. I'm going to talk to you today about the integrated composite sleeper, better known as the Hedgehog. So I want you to bear two questions in mind while I'm doing this presentation. First question is, what would happen if Formula One designed a sleeper? So I'm just going to quote the famous Colin Chapman of Lotus fame in the 70s. And his design ethos was ever so simple. It was simplify, then add lightness. So I'm going to repeat that again. Simplify, then add lightness. So bear that question in mind, please. And the next question then is a network rail vision for CP7, which is three words: simpler, better, and greener. So can a sleeper be simpler, better than greener, and help Network Rail develop its vision? So again, that's the other question. I want you to contemplate while I'm talking about it and maybe ask yourself at the end. So the carbon emissions associated with track renewals. We've all been told that we've got to reduce carbon. We're all aware about the net zero carbon targets and stuff like that. So from a track renewals point of view, we decided to have a look at what that was. We was a little bit surprised that actually the actual physical activity of a track renewal is only 2% of the embedded carbon. So things like the welfare, the RRVs running around, even the locos is 2%. So where is our embedded carbon? Well, the bulk of it is actually in the rail. Obviously, steel, iron, very carbon intense products. 63% of it is in the rail. I'm told for every metre of rail produced, 2 tonnes of carbon is released to the atmosphere. However, work is being done, green rail with electric arc furnaces, which will bring that down significantly. Then we look at the sleepers. 31% of the embedded carbon is actually in the sleepers itself. So what are we doing at the moment to reduce that? Well, we're swapping out timber for composite sleepers, such as the side-cut sleeper. We're working on bearers for S&C as well at the same time. People like Darren Sharp and Jamie Wilkes are leading that. With concrete, we're basically doing a lot of work with concrete to reduce the amount of cement. So SEM2 and SEM3 concrete sleepers, basically seeing the carbon reduced from probably about 80 kilograms in the sleeper, embedded carbon down to about 40, and hopefully we can get lower and lower. We also have things like Theocrete, which is the sulfur sleepers, which basically uses sulfur as a binding agent, and that massively reduces the embedded carbon, but there's quite an expense on it. And then finally, obviously, we've got the ballast. It's only 3% of the embedded carbon, but again, work is being done with recycled blended ballast, so we can start using that with track renewals. So that's a little bit of a picture where our carbon emissions are associated with track renewals and what we're doing to date to deal with it. But I'm going to concentrate on sleepers. So the question is can a composite sleeper then, because that's already a big improvement on wood and concrete, can it be made simpler, greener and better? So a base plated composite sleeper is about 36 kilograms of embedded carbon in there. But actually, where is that embedded carbon? It's not actually in the composite materials itself, it's actually in the base plate. So a PAN 11 base plate has about 15 kilograms of embedded carbon in it. Clearly there's 2 of them on each sleeper. So straight away, 30 kilograms of embedded carbon is just associated with the base plates. So if we can reduce that, we can really, really impact the amount of embedded carbon in a sleeper. So do we have an alternative to base plates? And we definitely do. We have basically the Pandrel fast clip system, which is an embedded shoulder into a concrete sleeper. So the question was, can I get that Pandrel fast clip system and embed it into a composite sleeper. The other advantage of a fast clip as well is they lend themselves far better to mechanical with track renewals, obviously using things like the Robel and chambray bites for clipping up and the sleeper bales. And also fast clip system is the network rail preferred fastening system for track renewals. So I set a challenge, which was to design and produce a mechanised renewable compatible composite sleeper with an integrated Pandrel fast clip shoulder, and I also thought I might as well go one better and make it compatible for Cat 1A track, because current composites are generally Cat 3 and below, but some of these sort of newer, heavier ones can also do Cat 2 now as well. But again, not very compatible with track renewals because they're using base plated systems. So what I wanted to do was set a project goal to produce, design, and product approve and install a composite sleeper with the following properties. As I sort of say, Cat 1A track compatible. I wanted something that could replace a G44 concrete sleeper, but also at the same time have something that could be used for an EG47 shallow depth, supporting third and fourth rail if possible. Needed it integrated with a Pandrel fast clip system, so it's standardised across the network. Clearly lower the amount of embedded carbon as much as humanly possible. Talking about climate change, obviously make it resilient to climate change, i.e. we're going to put this in the track so it's better perform with a changing climate. And if possible, actually lower than the cost of current composites. So quite a tall order. So what was the result of the project? Well, the result of the project is behind me, which you can't see me, is the Hedgehog Sleeper, manufactured in conjunction with Landcourse Engineering Products. So greener, it's got 90%, up to 90% less carbon than a hardwood sleeper, and about up to 79% less carbon embedded than a concrete sleeper. It's greener, it's made from 90% recycled materials, and the end of life is fully recyclable. It's better. It exceeds the performance of concrete sleepers, and I'll go into the presentation to show why that is. And it's simpler. So we have one single design, which basically replaces a shallow depth and full depth sleeper, but is also third and fourth rail compatible. So a little bit more information on the sleeper, then I'll go into how we went about achieving it. So the size is basically the same length as an EG47. It's the same width for a G55, and it's the same height as an EG47, and I'll explain why that is. It weighs a mere 78 kilograms compared to 308 kilograms for a G44 concrete. The estimated embedded carbon is about 12 kilograms. The reason it's estimated is that has to be independently verified, and we're in the process of doing that now. The fastening system can be either Pandrel FE or FC or a Voslo screw. Has greater lateral resistance than the G44. Compatible with our existing sleeper bales, the new track constructions train, the Belford train, our network rail track relay system, and our ballast cleaners and undercutters. It's designed for use in all track categories, both non-electrified, AC and DC track. Okay, so let's have a little bit of a story about how we ended up with the Hedgehog. So we started off with a tender and initial design. So working with the likes of Darren Sharp and some of the people in the technical authorities, Jamie Wilkes, we put together a specification and issued a PIN notice to see if we get some of our current sleeper suppliers, especially in the composite market, interested. We ran a tender in January to April 23, and the winner was a company called Landcourse, who are a Dutch company who specialise in recycled plastic making engineered products. And they already had a sleeper in service, which is the Type 102, in places like Holland and Belgium. And as you can see straight away, their composite is it's not the normal just rectangular form of a normal composite. It's actually got quite a bit of the sleeper removed to allow the ballast to entomb the sleeper. So rather than rather than using the mass of the sleeper, it actually uses the mass of the ballast to actually offer lateral resistance. So that was this sleeper here was the building blocks of the Hedgehog. So we talk about recyclable materials. So I'll show you at the end of it. In my hands, I have a bag of ground up bottle tops, and to the left of me is a beer crate. The actual Hedgehog sleeper is made from bottle tops and beer crates, so it's fully recyclable. It's high density polyurethane plastic, which is wholly recyclable at the end of its life. It's basically ground up and can be used again many times. The sleeper itself is injection molded, so as it's entered the mold, it goes in molten, and as it cools down, out pops a Hedgehog. It's very recyclable and very environmentally friendly. As I say, at the end of its life, totally recyclable. So we talk about a circular economy. That's really good. So some of the features we built into it is I said earlier that it outperforms a concrete sleeper. Well, I need to put my money where my mouth is and prove that. So lateral resistance. So the black line on the chart is the Hedgehog sleeper, and the red line is a G44. So we've got greater lateral resistance than what a G44 can offer. Now, why is that? So a G44 weighs 308 kilograms. So it's got a lot of dead mass to start off with. So you need an awful lot of force to move 308 kilograms, where the Hedgehog sleeper is only 78 kilograms. So we need to engineer the sleeper to build in lateral resistance. So the first thing we could do is the bottom of the sleeper. As you can see, it's not a smooth base, it's indented. This helps keen with the ballast. We then shape the sleeper so actually it mobilises as much of the ballast as possible. Now, when I say mobilise, I mean the sleeper then uses the mass of the ballast to compensate for its own lack of weight. So the sleeper is designed to be entombed around these fins, around these wings, to mobilise the amount of sleeper. There's probably about 40% less material in a Hedgehog sleeper than there is in a concrete sleeper. But where that 40% material isn't there, actually it uses the mass of the ballast to compensate. So actually, although the sleeper is only 78 kilograms, by the time you add in the ballast mass as well, the sleeper ends up weighing about 208 kilograms, which compensates a great deal for the lack of weight of the sleeper. So we've done lots and lots of tests on that, observed how the ballast mobilises, and this is why we not only have the shape of the sleeper here, wide of the sleeper foot, but these wings to ensure that the ballast is fully mobilised, and that gives us the lateral resistance we require. Other factors about the design as well is this is the bearing of the sleeper. So where you want the load is directly through the rail and then spreading out in a sort of pyramid shape below the foot of the rail through the sleeper into the subgrave. And the concrete sleepers, these two here, are particularly good at doing that. The load passes through into the foot of the sleeper. The only trouble with concrete sleepers as well, though, is because they are so stiff, you also get a lot of bending moments in the centre of the sleeper. So you get an awful lot of load here. So you end up with an unbalanced sleeper. With the Hedgehog sleeper, we actually designed it to be balanced. So we get the most load coming down the pyramid from the sleeper. And in order to achieve that, if a sleeper's too long, it basically shifts the load towards the end of the sleepers. If a sleeper's too short, it moves the load to the centre of the sleeper. So this is why short ending isn't precisely a good practice if you can get away with not doing it. So what we've done with the Hedgehog is measured that to make sure that the width of the Hedgehog sleeper gets that the sort of sweet spot of loading in the sleeper. And we sort of use finite element analysis to work out what that is. And as you can see, we're actually spreading the load very uniformly for the sleeper. So that then goes into the subgrade, which gives us a better balanced sleeper, stops centre binding, and hopefully gives us a longer ballast life as a result. Again, some other considerations, it's all very fine saying height, length and width, but we have to set ourselves some natural constraints. So we know that with the things like the track relaying system and the NTC, the widest sleeper we can go through there is 2.55, which is the same as an EG47. So that set us the maximum length of the sleeper. Height of the sleeper has a great deal to do with the mobilisation of the ballast. So when we took the height of a G44 at 160, that actually gave us the greatest lateral resistance. But then when we sort of did it at the same height as an EG47, it reduced the lateral resistance down a little bit, but it's still greater than a G44. So rather than having two sleepers, we actually had a consensus to go for a sleeper the same height as an EG47. So it's not quite as much lateral resistance as we possibly could get with a fuller depth sleeper. But that one sleeper design then does the same. It outperformed both G44 and an EG47. But the maximum width we could go to, because obviously the wider the sleeper, the better that lateral resistance would be, was what was compatible with our current Tampa fleet, which we know to be 350 millimetres, which is the same as the G55 cable management sleeper. So that's how we ended up with the dimensions of the sleeper, by combining all those things together. We then looked at varying different materials. Now, I know very little about plastic properties, so I won't claim I will do, but we did find out an element analysis and different sort of high density polyurethane to see which would work best with the shoulder and transmitting the forces. And we found that this HS material was by far the best. Again, 100% recyclable. It doesn't rot, doesn't splinter. It's got their excellent damping properties. It's made from a very similar material as an undersleeper pad. So all the benefits of an undersleeper pad are baked in, literally baked into the Hedgehog Sleeper. So it gives excellent damping properties. If you want to, you can machine it exactly the same as wood. We coloured it with black carbon, which offers a great UV blocker. So the sleeper will last, well, indefinitely, effectively. And any degradation due to sunlight only affects the 1/10 of a millimetre of the outer surface. So the actual structure is absolutely sound throughout its lifetime. We then looked at the fastening. So it was very easy to say, well, we'll just take a flat skip shoulder and mould it into some plastic. If only life was that easy. What we found out was plastic and concrete, wouldn't be surprising, behave very differently around the shoulder. So we took the existing pandrel shoulder and we added a sort of plastic insert and then a steel insert to see how that would perform. Once we knew that was performing well, we then cast a whole new shoulder. So we cast one for FE, we're casting one for FC, and there's also a sort of middle one, which is the FCA, which is very similar to the Boslow screw. So we had to create a whole new shoulder, and Pandrel's have been supporting on us in this process for the concrete, for the integrated sleeper. So it wasn't just a case of using the existing Pandrel product, we had to create a new product. So it's a bit like an iceberg. Everything above the surface is the same, but everything below the surface is very, very different. But we're going forward at the moment with FC, because that's the common shoulder network rail uses. And that would help us with the initial product acceptance, because it's been deemed as CSM non-significant as it's already in service. But we are also developing an FE shoulder, and the reason for that is the FE shoulder uses half the amount of steel and iron as the FC shoulder, so that'll lower carbon even more going forward into the future. So just going to show you some of the sort of videos of the testing now. Yeah, that's plain. So this is sort of what they call the angle test, and this is basically to see that the simulating the train pushing down on the sort of head of the rail and make sure it doesn't pop out the fastening. So we've done all that tests, and as you can see here, we've done some pull tests to make sure that the shoulders don't pull out of the sleeper. So it's passed all those, no problem whatsoever. Static bend testing. So we do a static bend test, which is running in the background, but is really, really slow. Now, if that was a concrete sleeper, at some point it'll start cracking and maybe break altogether. as you can see, is the loading on that is really slow, but we're getting a slight bit of deflection in the sleeper. But as soon as the load's taken off, the sleeper returns back to its normal state. So that was really encouraging. And the video on the right hand side is, I'm just trying to get it to play again. Excuse me. This is the dynamic system testing. This has been done at the University in Munich in Germany at the moment in time, and this is basically simulating those sleepers performing under traffic. We've done one test. We found a bit of an anomaly with one of the sleepers which came off the test. We've done some slight design changes to account for that, and we're just rerunning the tests at the moment. But confidence is very high. So that's the equivalent to basically, I think it's I don't know if Darren Sharp's on the call. It's basically equivalent to that sleeper being in track for 30 years. And then just this is just for people's information really. So this is the material test. So we've got an RSJ pushing down onto the sleeper. As you can see, the bearer has stayed intact, but the RSJ is actually bent. So that sort of gives you an indication of how strong the material, the high density polyurethane is. It's stronger than steel. Going forward, we mentioned we needed the compatible renewal. So the sleeper is designed to be compatible with our 4 and 7 sleeper bales, compatible with our existing fast clip clippers, which is good. Works with the TRS and the NTC. And because of the weight of the sleeper being 78 kilograms, we can have a 14 sleeper bale, as you can see there, which will allow us to install track far quicker. And I know some bale designers have actually got some ideas how we can make a 28 sleeper one, but that's their intellectual property, which I'm not at liberty to share at this moment in time. A little bit about quality assurance. So it's an engineered product again. So we're using 3D scanning. So every sleeper that will come off the production line will be scanned with a 3D scanner. Within the 3D scanner is the CAD model. And basically, we measure all the dimensions of sleepers, and it gives us an image like this. So green is actually 2-dimension, and if you go red, it's a plus dimension. Going down into blue is a minus dimension. All the blue in here actually is well within what we'd accept in the world of concrete. But what we're trying to do as part of the product is get all this blue into the green, so it's perfect every time. Now, the reason for that is when we mould a sleeper, the mould is bigger than the actual finished product because the plastic has to cool in the mould. So where we're working now is just to finally get these last little bits of blue off the sleeper pad area to make sure they're perfect every single time. But as I say, that is well within acceptable tolerances for a sleeper. We've got steel reinforcements going for the sleepers to add us a bit more structural strength. And again, to make sure they're all in the right place, not touching the shoulders and all that sort of stuff, we use X-rays to check where the rebar are. So they really are a quality assured engineered product, well and above anything being manufactured currently. So there we are. So this is me at Innotrans, massive big rail show, and showing off my Hedgehog Sleeper. And obviously we've got the fast clip system at this end, and we've got the Boslow system this end. So there's a market across Europe and the world for this sleeper. I'm just going to play a video, so I'm just going to have to share another screen. So hopefully you can. Oh my God! Apologies, 1 second. I need to include computer sound. Bear with me a second. Just going to play a video, and then we'll close the presentation. So Network Rail are committed to meeting their net zero targets, and currently in track construction there's a lot of embedded carbon. Over 60% of that is associated with the rails. Technologies such as electric arc furnace will hopefully help us reduce that embedded carbon. The next biggest culprit though is the sleepers, and that's over 30% of the embedded carbon. So that set me on my task of trying to find a composite sleeper which matched the properties of concrete, but also at the same time allow for mechanical track renewals using an integrated fastening system. The Hedgehog Sleepers are actually a development of an existing sleeper produced by a Landcourse engineering product. So this is where we've worked in conjunction with Network Rail and Landcourse to share the future IPR on the product. To set up a sleeper production line in the UK is a relatively simple process. The injection moulding system is probably about the size of a tennis court. So we could set them up quite locally at railheads, but these could be regional nodes. So actually there's great potential for UK jobs in the Hedgehog Sleeper as well.
We're now approaching the 200th anniversary of the railway. And throughout all that time, the railway sleeper has looked like something that came out of a Victorian sawmill. But for the first time, we've completely re-engineered it. We've produced a railway sleeper from recycled plastics, from old bottle tops. A railway sleeper that lasts longer, that's got much less embedded carbon and performs better.
Core company values are around simpler, better, greener. Research and development plays a significant role in delivering on those values. So for me, it's really important that we enable our routes and regions to actually deliver on that mantra for the company. But this is a really good example of a kind of tangible product in the ground that's going to deliver a lot of efficiency through greener benefits, cost, durability, asset life cycle. The passion that's gone behind the project is really evident. It's a really easy sell for me. This feels like it's actually could be a game changer.
I'm really excited that we've taken a product which is as historic and tried and tested as a traditional railway sleeper, and we've been able to completely reimagine and reinvent what we think is possible with it, not just in terms of it helping us meet our sustainability targets, but also the future benefits that it will have for us in terms of ongoing maintenance benefits and even benefits during construction due to its lighter weight. I think the key benefit for me is that at the end of their life, these assets can be ground up and essentially remade into new sleepers. The ability to put them back into service at the end of their life is a massive win. Hopefully it should drive fewer maintenance interventions, but I think the good thing is that when maintenance is required, the fact that they're lighter just means that those maintenance activities will be easier to plan and safer for the people involved. Typically a railway machine will pick up a maximum of 7 sleepers and install them at any one time. Again, because it's such a lightweight sleeper, there is the potential to massively increase that and potentially even double the amount of sleepers we can lift at one time.
The opportunity of the composite sleeper, the Hedgehog Sleeper, when you consider what we have to do as an industry, we need to maintain the railway, and we need to renew the railway when it's worn out. And all that time we've got to maintain specific safety and performance levels. But what I particularly like about it, with its innovative shape, it has a lot more lateral resistance. That's resistance from side to side. Why is that important? It's because when our track is heated in the summer, it can resist more effectively what we call buckling forces, lateral forces. So what we need in materials and technology which can resist those temperatures so we can maintain a highly performing, highly safe railway. And this does just that.
All projects that come through the R&D governance are benchmarked against each other, so which ones give us the best return on investment, which ones are core R&D activities, which ones are the routes and regions likely going to want to deploy at the end of it, because ultimately that's what we want. We don't want a technology that sits on the shelf. We want to deploy across all the routes and regions. And we very much use the regional representatives at our R&D board to give us the steer about which projects to prioritise, and that we ultimately get something that improves our railway. So now we've got an approved design, we want to trial it, we want to put it into the real world. So we're going to be installing several hundred of these sleepers on a trial site in Wales, and that will give us the real world data that we can share with the business to show that they are as effective as we want them to be, and it will give you the benefit that we think it will around improved track geometry and ease of installation.
So something that lasts twice as long, has less embedded carbon and is fit for purpose. We're really proud of this project.
But yeah, so I'm just going to go back to my slide deck and a couple more slides, then I'll open to questions. So if you going back to the start of the presentation, I basically asked you to bear two questions in mind. So network rail visions for CP7, simpler, better, greener. So simpler. So we have a single sleeper design. We've got no base plates. We've got no screws. So we got no additional fitment of base plates required after the sleeper's been manufactured. I think that's simpler personally. Better, well, it's lighter. It's got better lateral resistance. It's Cat 1A track compatible. It's lower cost than a base plated composite sleeper. Compatible with mechanised renewals. No need for additional undersleeper pads. Better balance leading to lower ballast life and lower maintenance. Sounds better to me, but I'll let you decide that. And greener, well, it's made from recyclable materials. Got a longer service life. We don't know exactly how long, but 50 years is not out of the question, maybe greater. Transportation, because it's lighter, so it costs us less fuel to transport it around, and it's lower embedding carbon, and at the end of the day, it's fully recyclable. So I think personally, a sleeper can be simpler, better than greener. And then the final question really was, what would happen if Formula One designed a sleeper? So back to Colin Chapman, simplify, then add lightness. My gut tells me that Formula One would design a Hedgehog Sleeper. So thanks for listening, and I'll open to questions now.
Thank you, Nick. That was really good, really informative, and it definitely does feel like the F1 of sleepers, doesn't it? So I'll open up to some questions in just a second, but while anybody's adding them to the chat now and people having a think, I'll just ask one of my own quickly. What's the ultimate aim for this over say a 10-15 year period? Is it your plan that these will replace concrete sleepers or be an alternative to concrete sleepers? I think initially coming into it, my thought was maybe more around timbers, but looking at that, they really do seem to have some excellent advantages.
Yeah, so I think it's the word is complement. Are we going to get rid of? Could it totally replace concrete? Well, the answer is yes, it probably could. Would you want to totally replace concrete? Probably unlikely. As it stands, I think concrete's always going to be probably a cheaper solution, especially at the moment in time. But again, that's all down to volume. But it's definitely the price point is somewhere between sort of right in the middle between what a concrete sleeper costs and what a base plated concrete composite sleeper costs. So tunnels, viaduct, bridges, places like that on high-speed lines, it actually lends itself quite nicely to that. But again, if we're serious about net zero, and we can only take concrete so far in reducing embedded carbon, so at some point, actually, it no longer becomes a financial case. It actually becomes, well, this is our way of getting the carbon down as low as possible. So I think it's complement, Richard, would be my answer on it.
Okay, thank you, Nick. Stuart, I noticed you had your hand up. Do you want to ask a question?
Okay. Has there been any interaction with the National Measurement Train team to see if this works or could be made to work nicely with plain-line pattern recognition?
Yeah, Stuart, he was quite faint, but I think I heard what he said. So we're working with the technical authority, Jamie Wilkes and Darren Sharp, and it's again back to the iceberg analogy. The bit the plain line pattern recognition sees, i.e., are the clips in and out, are fully visible to the train. So obviously we've got to prove it in track, but it has been designed with that consideration.
Thank you.
Thank you, Nick. I'll go over to the chat now. There's a few questions in there. I'll start going through those. So Toby asks, are there any issues that are anticipated due to the initial lateral resistance being lower? Again,
I'm not an expert in this. They're sort of like the initial hooking force. It's a shame Darren Sharp isn't on the call. Yes, the initial lateral resistance is less, but only marginally. But no one's raised any concerns as of yet. But again, it's back to this. We've got to get it into track to actually physically find these things out.
Okay. And then Patrick asks, I think this came up at round about the point where you were talking about the finite element analysis. What were the anomalies you found when you were doing that?
Sorry, is Patrick on the call? Could you sort of maybe build on that question a little bit?
Yeah, Patrick Dickinson.
Can you hear me? Yeah, there we go. I'm off. So yeah, it was during when you're doing load testing. Yeah, you said that you had to go back and tweak the design, and you're still running some more tests because you found some anomalies. And I was just curious as to what you actually found.
Well, basically, when we did the initial load testing, one of the sleepers was absolutely fine, but the second sleeper there was a small hairline sort of fracture around where one of the fins was. So it's just we had to just add a bit more material to where one of the fins was.
Okay, and you're just waiting for the results now of the secondary test.
Yeah.
Brilliant. Thank you.
Okay, thank you. Following on from that, so from Jan, would you expect higher vibration in track due to the lighter weight sleeper? Could this impact noise and vibration and potentially corrugation?
Well, the sleeper, as it said in the presentation, actually improved the dampening of the forces, so it should be less vibration.
Okay, excellent. So next question from Ahmed, I think. So there's 5 questions here, so we'll rattle through these. How do Hedgehog sleepers perform under prolonged exposure to varying climatic conditions and extreme loads over the decades?
Well, it's like all I can say is they're made out of plastic, and one of the problems with plastics, they don't degrade. Fortunately, this is recycled plastic, so as we say, we've done sort of laboratory tests on the materials. The material is well understood in other fields, so you know, an extremely high density polyurethane is an extremely resilient material.
Okay. Are higher initial costs and specialised installation methods justified by the extended lifespan and reduced maintenance?
Well, there's no specialised installation techniques. It's exactly the same as laying a concrete sleeper, and the costs. So they're not much more expensive than a concrete sleeper, but again, that's down to the route asset manager to decide what they wish to put in. It's nowhere near as expensive as a base plated composite, but a base plated composite can't be used in Cat 1A track. However, from a whole life cost point of view, it's considerably cheaper, but yes, the initial cost of the sleeper is slightly more. Again, that's an asset manager's choice what material they use.
What is the overall environmental footprint of manufacturing and disposing of Hedgehog sleepers compared to traditional sleepers?
That's what the embedded carbon calculation is for. So when we started this project, a concrete sleeper estimated embedded carbon was 80 kilograms CO2 equivalent. That's now being brought down briefly like Chem 2, Chem 3 to about 40 kilograms. And that embedded carbon is the carbon of the whole life cycle of that sleeper. So we're down to about 11 to 12 with the Hedgehog sleeper.
Okay. Are Hedgehog sleepers equally effective across all types of railway system, high speed, freight and mixed use?
Well, they're certainly designed to be that way, but as I say, we haven't actually installed any in the track yet. So part of the product approval process is to actually get it in the track system and then actually understand once it's in the track system. But all the tests we've carried out, the EN testing and stuff like that, is exactly the same testing that will be carried out on a concrete sleeper.
Yeah, okay. How well does Hedgehog sleepers integrate with advanced track monitoring systems and rail fastening technology? So I guess that could be PLPR, which I think we've covered already, so I might skip on from that one to how easy is it to repair damaged Hedgehog sleepers, and what are the options for recycling, reusing? So I think you covered probably the recycling, reusing in an earlier answer, so just the damaged part there.
Yeah, so first of all, they're far more resilient than a concrete sleeper. So they're probably more, we've got to prove this, but The existing Langhorse sleepers made from the same materials, they're far more resistant to, say, for example, a tamper strike. So it's pretty hard to break them in the first place. One of the things we have asked if it is a shoulder's damage, which is quite a common thing, is can we core drill out the shoulder and replace the shoulder? So that's one of the, it's sort of like it's on the risk register and it's part of the project we're carrying out to make sure that we can actually change the shoulders. But ultimately, it's like any sleeper. If it's beyond sort of repair, it would be a case of sliding out the sleeper and putting a new one in. So these things are being considered. Yes.
Okay. Danielle, you've got your hand up. Do you want to ask your question? Are you there, Danielle?
Sorry, that was an error. My laptop
Okay.
had a bit of a meltdown.
Not a problem, not a problem. Okay, so moving on from there. So next question. For my information, why is the force value at 25 millimeters displacement chosen?
Good question. I don't really know. It's what is required in the EN norm for the test.
Okay. And then, so from Daniel Pike, dimensional stability over time is traditionally an issue with recycled polymer products. What assessment has been done to assess dimensional stability with age? And the second part of that question around cost, I think you've already covered.
I don't quite understand the question, sorry.
Daniel, do you want to elaborate at all on that, if you're still on?
Yeah, still on. Just a question. Traditionally, recycled polymer hasn't got the best dimensional stability in the world over time, particularly with water ingress and things like that. Has there been artificial aging tests and things? Has that been considered? Because obviously the key dimensions we're looking for is gauge here. Is that stable over the 40-year lifetime, whatever the lifetime is, the increased lifetime of this product?
Well, the honest answer is I can't 100% answer your question. However, high density polyurethane, but I put a slide in it earlier. It is impervious. It is impervious to absorbing water. It's 100% waterproof and 100% rock proof.
Okay, thank you. So next question is from Paul. Have you investigated what the effect on ballast rotation and migration under dynamic track operation has on the sleeper's performance?
Yeah, well, that's what, when I was talking about the ballast mobilisation, that's exactly what we measured. We basically, again, the laboratory testing, we put cameras above the ballast to see where the ballast drifted or the ballast moved under load, and that's basically why we have three wings, because we tried it with no wings, 1 wing, 2 wing, 4. We tried various things, and we found the 3 wing configuration was the one which mobilised the most amount of ballast, but also prevented ballast drift as well.
Excellent, thank you. And from Richard, is the sleeper made from 100% recycled plastic, or is there a new recycled mix element to it? How future-proof is the product if the use of plastics is reducing and limiting supply?
No, it is the plastic elements are 100% recyclables. So it's high density polyurethane, and I say it's things like bottle tops, beer crates, and there's there's lots and lots and lots in the open market, which is fully recyclable at the end of its life. And again, one of the questions I quite often get asked is how many times it can be recycled. So I did ask the manufacturer this question, and the answer is at least 100 times. Every time you reuse something, it loses a little bit of its properties, but it really is negligible.
Okay. From Steve, so first of all, he says, I think this Hedgehog Sleepers brilliant. Well done, Nick, and all involved. Does this impact on tamping, as the ballast will need to be compacted in different ways to different ways to traditionally under a flat sleeper?
Tamping shouldn't affect it, because it's a bit like if you think about steel sleepers, they're also indented at the bottom, hollow at the bottom. The one thing it probably can't be done at the moment in time is stone blown, because the sides, the stone blower goes down the sides, but also that needs a flat bottom as well. So tamping is not a problem, but we can't stone blow these sleepers. But that's not really an issue because stone blowing is normally done towards the end of the ballast life when it's no longer tamperable. So the current generation of stone blowers are no good. But by the time these sleepers are in chack and at the point of maybe need stone blowing, then we'll probably be on a new generation of stone blowers, which then can be designed around the Hedgehog. If that helps.
Yeah. And then from Roberto, are short-ended variations being considered?
Yeah, so the actual sleeper itself is, we're not going to design a short-ended variation. The reason being because they're moulded products, so you need loads of different moulds. But you can simply chop a amount of the sleeper away at the end, so they can be short-ended. But again, back to the whole balanced sleeper thing is, yes, we can short-end them, but the preference wouldn't, and again, exactly the same as a concrete sleeper, would only be short-ending if we have to.
Okay. And from Michael, can the Hedgehog be deployed anywhere on the network for all track performance specifications? So I think you've probably covered that in terms of it's from 1A to 5, isn't it? It's approved, it'll be approved for. Is there any more on that?
No, exactly. It's going to be approved for Cat 1A track.
Okay. So Gavin, are the sleepers suitable for cleating cables? And if so, what fastening method would be needed? E.g., is it suitable for a Hilti HPS 1R impact anchor?
Yes, just to answer that, if I just share my presentation again, it'll be the easiest way of showing this. Apologies. Can you see my screen, Richard?
I can. We've got the video. Oh, there you go.
Yeah, yeah.
Come through to the presentation. Yeah.
So the sleeper's designed for third and fourth rail. So these holes are in every single sleeper. So the initial thing was, do we have a non-electrified, non-third rail sleeper and just get rid of the holes, or do we have one sleeper? But what we decided was these holes are bolted in anyway, so they actually lend themselves ideally for mounting things like AWS magnets, cable cleating. So every sleeper will have the holes in anyway, so we can cleat and stuff to that. But also the material itself, back to the other slide where it says very similar properties of wood, you can drill into this, provided you don't drill into the reed bars, exactly the same as a concrete sleeper, and just screw a cleat into that as well.
Thank you.
So it should make our S&T colleagues' life a bit easier having to drill stuff. It's already pre-drilled.
Yeah, thank you. Hugh, you've got your hand up there.
Yeah, I was glad that you went back to the presentation. When you made the comment about cutting the sleeper short, I was thinking in my mind about that effective plate that you have at the end of the sleeper itself. So cutting that away would actually reduce the lateral resistance on the side quite considerably, because that double acting plate was something that I thought was a significant benefit with the design.
Oh, absolutely. That's what I said. It can be short-ended, but you are compromising the sleeper by doing so.
Thank you.
Thank you, Hugh. Okay, so we'll do the last few questions, and then we'll leave kind of a couple of minutes at the end to wrap up. So from Matthew, so question 1: some recycled plastics have steel bar for strength. Does this have a steel bar, and if so, how does this impact the embodied carbon and challenges of separating out the materials when recycled at the end of life?
Yeah, so it does have steel rebar because that increases the structural strength, same as a concrete sleeper. In fact, it does exactly the same thing as what it does in a concrete sleeper. At the end of the life, it's easily separated out. It's quite commonplace to use steel to reinforce plastic, and also additionally, at the moment in time, the steel isn't recycled. Well, it is recycled, but it's not. It still comes from traditional smelting processes. But going forward, that steel can come from electric arc furnace, which are, again, lower the carbon. But yeah, having the steel in there that is part of the 12 kilograms of embedded carbon. If it wasn't in there, it would be an awful lot less, but it would have a sleeper which is only compatible in probably Cat 2 track and maybe low.
How does that compare to the other recycled plastic sleepers such as Cycut?
Well, again, other recycled sleepers, I have to be careful what I say in this, is most of them don't have steel reinforcement, so that's why they can't take the higher axle tonnages. However, the companies like Voslo and stuff like that are using different blends of materials now, but also using steel in them to get the strength. So I can't remember the name of the material Voslo are using, but it's basically almost like a sand-based material to add mass, so it looks like a conventional bearer, but it is a recyclable composite bearer using steel reinforcement.
Okay, so just reading through this question. So, as the sleeper releases upon the, so I think that relies upon the ballast surrounding the sleeper, what changes are required to, okay, so that's normal laying and compacting, so we've kind of covered that with the tamping question earlier on, I think. So I'll move on to the next one, which is from Quirchmare. You mentioned the sleeper has USP properties included. The composite sleeper we have seen so far are much harder than the USPs used. They usually also do not create the same contact area and hence allow ballast projection due to the reduced ballast contact pressure. Is the sleeper soft at the bottom? Has it different properties at the bottom?
Well, when you use the word composite, you have to be really careful. Even concrete is a composite sleeper. You're using different materials to make a form. So some composite sleepers are made out of recycled car tyres. Some, like the second series, are made from glass fibre. The Hedgehog sleeper happens to be made from high density polyurethane. So all sleepers are made from totally different materials. So it all varies. But you got to remember the Hedgehog sleeper, the shape of the Hedgehog sleeper has been engineered to account for some of these properties. So, most composites are just basically a rectangular block. So they have no added value to it other than the fact they're rectangular. The Hedgehog sleeper is actually an engineered design product to provide additional properties over and above what the material itself can offer.
Yes. Thank you. I'll do one last question and then we'll do a quick look. So final one from Daniel. Have you assessed the vertical resistance as the lifts in use has previously prevented lighter sleepers being used in higher speed track?
Yes, again, this is quite a common question, and it's certainly on my risk register. So, as I sort of said, the sleeper is only 78 kilograms compared to 308 for a concrete. Excuse me, but because the sleeper's tapered, it gets entombed in the ballast. So actually, and I'll talk about this mobilisation of ballast. So the sleeper's designed to use the mass of the ballast also to add vertical load. So the sleeper's 78 kilogram, but if you do the volumetric calculations, and the mass of the ballast then is basically adds another. I did some rough maths because I knew I'd be asked the question. It takes up the overall mass of the sleeper to about 200 kilograms. So again, the engineered shape of the sleeper is designed to compensate for that vertical lifting. I've been asked by a few sort of people about, it's okay being lateral resistance. Can it resist a vertical buckle? They're quite a rare phenomenon in the first place, but they do happen. But again, it's like anything. It's until it's in track and we test these things. The honest answer is we will never know. But it is certainly designed. The lightness, is a design feature, but also it's a design risk. But the engineering in the product compensates for that, or we believe it compensates for that.
Okay, excellent. Thank you. So, right, just to wrap up then, I think from my point of view, Nick, it's a truly innovative product. I think, a lot of us have been in the industry a good while, and I know a lot of us have. You start to think there's not much change, is there, in the rail industry, but this does genuinely feel like something with the power to do both good and improve things, and is genuinely different. So yeah, phenomenal product. I'm really quite impressed by what I've seen, and definitely something for me to take back to my kind of asset managers hat in a little while, and have a think about where they'd be useful to us. So thank you for that. Thank you for a really brilliant presentation. I think we got up to about 210 people on the call at the kind of peak, which is a really phenomenal attendance. And obviously we've had a really spirited question and answer afterwards as well, which I know there's still a few questions unanswered. So if anyone has still got things, I'd just point you to the LinkedIn, on the PWI LinkedIn page, and there'll be a dedicated discussion post on this, which we can kind of all chip into if you've still got thoughts going forward on that. And as I mentioned briefly at the beginning, next session of these Lunch and Learns is on the 21st of January, and that will be on the complexities of train testing Midland Main Line's new overhead line equipment. But again, Nick, from me, and I think from everybody else, thank you ever so much. And that just brings us nicely to time. So thank you, and yeah, good afternoon to everybody.
Thanks, everybody. Cheers.
Thank you.
Thank you.
Thank you very much.
Thank you.